Hello, my dear students. Myself, Vineet Gupta. I'll be teaching you Structural Analysis 1. Let's start with today's topic axial force, shear force, and bending moment diagrams. Before starting with this topic, let us first understand what is a structure and how it is classified. The picture you can see over here is nothing but a structure. So structure is an assembly of a number of components like slab, beam, column, walls, foundation and so on, which remains in equilibrium. For example, when you take a beam which is receiving a load of 100 kilonewton and transferring it to column, the column has to give a reaction of 100 kilonewton so that the beam remains stationary held in that position. So it means equilibrium. The structure has also to satisfy some fundamental criteria for existence, such as it should have sufficient strength to take the loads. It should be stiff. It should be economical, durable, and compatible with the environment conditions and whatever conditions it is subjected to. From analysis point of view, structure is classified in two types. The first one being determinate structures and the second one indeterminate structures. Determinate structures are structures in which the reaction forces and moment at supports can be found out easily by using three equilibrium equation of statics, that is summation of fx is equal to 0, summation fy is equal to 0 and summation of moments is equal to 0. For example, a simply supported beam, cantilever beam, or overhang beam. If we take an example of these three beams, for cantilever beam, the end conditions, it is having three unknowns. For a simply supported beam, it is having three unknowns, two for hinge support and one for roller support. And for overhang beam, it is also having the same condition as simply supported beams. So in these structures, you have three equilibrium reactions and three unknown forces which can easily be found out by this method. And these type of structures are known as determinate structures. Indeterminate structures are the structures in which the reaction forces and moments cannot be easily found out by equation of equilibrium statics. The extra reactions are called as redundant reaction and it represents the amount of degrees of indeterminacy. Examples for determinate structures are simply supported beams, cantilever beams, single and double overhanging beams, three-hinge arcs, etc. Examples for determinate structures are simply supported beams, cantilever beams, single and double overhang beams, three-hinge arches, etc. Examples for indeterminate structures are fixed beam, continuous beam, fixed arches, two-hinge arches, portal and multi-storied frames, etc. The cantilever beams has three reactions. Simply supported beams also have three reactions. Overhanging beams have two reactions. The continuous beams over here have more than three reactions. Fixed beams, cantilever and simply supported beam, all these have more than three reactions and it comes under indeterminate structures. These are examples for three-hinge arch, two-hinge arch, fixed arch and a typical frame building. This was a short introduction about structures. Now coming back to our topic, axial force, shear force and bending moment. Axial force, the forces acting along the longitudinal axis are known as axial forces. It can be tension or compression and its unit is Newton or kilonewton. The sign conventions for axial force are tension positive and compression negative. Tension means if the two forces are acting equal and opposite and away from each other at the ends, then it is known as tension. And if the two forces equal and opposite which are facing towards each other are known as compression. Now, second force, shear force. Shear force is defined as the algebraic sum of forces acting either on left hand side or right hand side of this section. It is known as Newton. But its unit is Newton or kilonewton. The sign convention for shear force are clockwise positive and anti-clockwise negative. For example, if you are taking any force which is on the left side of the section, then upward is considered as positive, and if you are considering any forces to the right side of the sign convention for shear force are clockwise positive and anti-clockwise negative. For example, you are taking any force which is on the left side of the section, then upward is considered as positive, while the same force, if it is on the right hand side, then downward is considered as positive. Vice versa, for the second condition, downward on the left hand side is positive. The sign convention for shear force are clockwise positive and anti-clockwise negative. For example, if you are taking any force on the left hand side of the section, then upward is considered as positive, while downward is considered as negative. And if you are taking any force to the right hand side of the section, then downward is considered as positive and upward is considered as negative. The other force is bending moment. It is defined as the algebraic sum of moments of forces acting on left hand side or right hand side of the section. Its unit is Newton mm or kilonewton meter. The sign conventions for bending moment are sagging bending moment positive and hogging bending moment negative. For example, if you are taking a beam and the moments at the end is causing the beam to move in such a way that it is forming a U shape, then it is known as sagging bending moment, which is considered positive. And if the moments move the beam in such a way that its shape is inverted U, then it is known as hogging bending moment, which is considered as negative. The nature of shear force and bending moment diagram for different types of loads are as under. If the loading condition is point load, then the slope for shear force is constant, whereas the slope for bending moment is linear or inclined line. If the loading condition is uniformly distributed load, then the slope for shear force is linear or inclined line, whereas the slope for bending moment shows a parabolic profile which is second degree curve. If the condition is uniformly varying load, then the slope for shear force is a parabolic profile or second degree curve, whereas the slope for bending moment is a cubic curve or third degree curve. Now let us discuss the important points while drawing shear force and bending moment diagram. The very first point is for simply supported beams or beams with hinge support at ends, bending moment at support is 0. Now you can look at this diagram. This is an example of a simply supported beam. You can see the bending moment at end is 0. Next point, for ends with fixed support, bending moment is not equal to 0 at supports. This is an example of a fixed beam. You can see at these two ends, the moment is not equal to 0. There is some moment induced due to fixed support. For no load condition between 2 points, shear force will remain constant. Now from this diagram you can see between point A and C there is no load. Thus the shear force is a straight line and it remains constant. It changes at point C where there is load, and then again it remains constant since there is no load between C and B. For cantilever beams, bending moment is zero at free ends. Now this is an example of a cantilever beam where this is the fixed support and this is the free end. Now you can see at free end the bending moment is zero. There is no moment at free end for a beam. That's it from this video. We are going to meet again in our next video where we are going to solve examples on determinate beams. Thank you.